In this lecture, we will introduce the notion of iterators and discuss the iterator interface.
In the last lecture, we talked about the collection interface, and we mentioned several of the abstract methods that were given to us that we can implement whenever we create a class of that interface. But there was also one method in there that we didn't get to just yet. Well, the thing is, the collections that implement the iterable interface must provide a method that's named iterator. This is that method that we haven't talked about yet, so we're going to spend some time talking about it here. This returns an object of type iterator. Now, what's an iterator? Well, the iterator is an interface that's defined in the java.util package. But you already have to import this package if you want to use the collections API, so you should already be doing it. But let me show you some code of what this iterator interface looks like. We have three abstract methods in here. We have a hasNext method, a next method, and a remove method, and we'll talk about all these in a little bit. The idea of the iterator interface is by using this iterator method, any collection can create an object that would implement the iterator interface. And then we would simply return the object, or at least the address of the object, to the client. So this method would internally store this notion of a current position. And that's because, unlike arrays, we do not have an index. Dealing with linked lists, there are no indices for the nodes of a linked list. We have to use an iterator to access a node at the current position of the linked list. So think of this iterator as just kind of like a marker of where we're currently at in the linked list, and we can move the iterator as we traverse through the list. This iterator would tell us where we're currently at in this linked list. Now, the iterator itself is simply just a reference variable that would point to that specific node. Like I said, think of it like a marker or just some indicator of where we're at in the list. So any modification that we would want to make to a specific node would go through the iterator. Since we can't directly access a specific node because we don't have an index, we use the iterator to indirectly access the node. So if we want to make changes to the node, we would use the iterator, which is currently pointing to that particular node. And we can actually have as many iterators as we want. Now, you could have way too many, but you can have like 5 or 6 different iterators for a linked list. And then it's also worth noting that any collection can have an iterator. So it's not just a linked list that can have an iterator, but any type of data structure that's in the collection class, the collection API, any of those can have iterators. Let's talk about some of the methods that were given in the iterator interface. We'll start with the next method. So each call to the next method would give us the next item in our collection or in our list. So the first time we call next, it's actually going to give us the first item. And then if we call it again, it would give us the second item. If we do a third call, we get the third item and so forth. So each time we call next, we're going to be moving our iterator to the next node or the next item in our collection or list or whatever the data structure is. The hasNext method can be used to let us know if there is an item, or specifically if there is a next item. So before we call next, we can call hasNext to see, is there another item in this collection? And if so, then we could move on to it. Otherwise, we would say that we're at the end of our collection. Now, the compiler does something a little interesting that involves the for each loops, because one of the purposes of the compiler is to take code that's written and rewrite it in a way that's more efficient. So whenever the compiler sees a for each loop that's being used as an object that is iterable, or an object that is using the iterable interface, it actually does a couple things. First, it'll actually replace the for each loop with calls to the iterator method in order to get an iterator. Then it's going to call the next and hasNext methods. So instead of actually using the for each loop, if it can use an iterator, it's going to replace the for each code with code that involves calling the iterator method to get an iterator object, and then using a while loop that says as long as there is still an item in the collection, we're going to keep calling the next method. Let's go back to our print example from the other lecture and see how the compiler would rewrite that routine. So we would have something like this. To take a look at the body of this, this was our for each loop that was printing each item in our collection. So now what the compiler does is we create an iterator by calling the iterator method. So that's being done right here. So that's going to be stored in ITR, and that's of type iterator. And then we have our while loop that says as long as there's still something in the collection, so we're not at the end, so we have this hasNext method right here, we're going to have our item, and that's going to store the next item in the collection. So here we're just basically getting memory addresses of each item in our list. So we have our next method being called here, and that's being stored in our item variable. And then we would call the printline method to print the contents of that. But what we see here is this, it's completely rewritten from using a for each loop. Now this only works if the collection that we're using can use the iterator methods. Now I should end this by noting that the iterator interface does have a limited set of methods. It just has the iterator method, hasNext, and next. That's it. There isn't anything else. So because of that, it's really difficult to use this iterator interface for anything more than traversing through some collection. There is one more method in the iterator interface. So I may have just lied to you in the last slide. My bad. We do have the remove method. And what this simply does is we can remove the last item that was returned by the next method. Another way we can phrase that is we're just simply removing the node that we're currently at in the iterator. So whatever node we're currently looking at, we can remove it. Now the collection interface also has a remove method. So we have remove methods for both the collection interface and the iterator interface. But it's actually better to use the one from the iterator interface than the collection one. There are several advantages with using that one. The biggest advantage is that if we use the remove method from the collection interface, we have to find the item first. So that's going to take some time to search for the item before we can remove it. If we already know what item we're looking for, it's a lot less expensive because we're just saying remove the current one instead of having to search the entire collection to find it. So it's actually better to use the iterator version of it because we already know exactly which one we want to remove. We don't have to search for it. Now there's one more thing you need to mention about iterators. If we use an iterator directly, there is a major fundamental rule that you have to keep in mind. If you make a structural change to the collection that you're iterating on, such as adding an item or removing an item or clearing everything, then the iterator that you're currently using is no longer valid. In fact, if you try to use that iterator again, you're going to get an exception. So what this means is do not get the iterator, do not call the iterator method until right before you need to use it for iterating through your list. Now there is, I guess, an exception to this, for lack of a better word. If your iterator invokes its remove method, instead of invoking the remove method from the collection, the iterator is still valid. It actually has code that will allow it to obtain another node and still continue. But if you make any other structural changes aside from having the iterator itself remove something, then you're going to get an error and you can't use that iterator anymore.